Hello, this video is going to go through problem number 9 out of section 4.2 from our textbook and show you how to deal with the scenario where you have 3 equations instead of 2, but we still have 2 unknowns. But this, what I'm about to do can be expanded to if you had 3 unknowns or more. And so this is again the Gauss-Jordan row reduction modified method that's taught in our textbook. And so our very first step again is to take our equation, our system of equations, and write it as a matrix. And if you have more than 2 equations, however many equations you have, that's how many rows are going to appear in your matrix. Again, you're using the coefficients that correspond to each of your variables and the total. So we have our x's, then our y's, then our totals. And so the first equation is going to translate into 1, 1, 1. The second equation would translate into 3, -1, 0. And the final equation would translate into 1, -3, and -2. Be mindful of those negatives. It's very easy to leave those off, and then that'll give you a wrong total along the line. So be mindful of that. We will continue through the steps like we did with the 2 equations scenario. So we're going to start with the very first row. Find the first number in that row that is not a 0, which is going to be that very first one. And that's going to be your pivot number. The pivot number designates again a pivot row and a pivot column to help you through the process. The pivot row is the row that's not going to change in value. So we can leave a little bit of space to write our row operations. So leave some space here. That row number 1, 1, 1, and 1 will transfer over unchanged, which means that the other 2 rows, rows 2 and 3, are going to change in value. So we're going to leave those open. When you're working through these problems, you are required to pair the pivot number up with one other number from its column that you're going to try to then turn into a 0 as a total. So we have a 1 as our pivot number. We're going to pair it up with the 3, and then we'll come back later and take the 1 that's the pivot number and pair it up with the 1 that is not the pivot number. But you can only do one pairing at a time. So let's pair up that first row and that second row number and focus just on that column. So between a 1 and a 3, try to create a 0. And hopefully you're thinking of 3 and 3. When subtracted would give you 0. So if we took 3 times our row 1 value and subtract the row 2 value, that's going to create a 0 there. So remember, that's your row operation, and you're going to write that in between the matrices as a set of directions that you're going to use for each column. So we're going to take 3 times whatever's in the row 1 number, and then we're going to subtract whatever's in the row 2 position. And that's going to give us our answers to our row 2 in the next matrix. Whatever number is not the pivot number, its location is going to be where you write your row operation, and the answers you're going to generate from those calculations will go in its row. Taking one column at a time, 3 times row 1 minus row 2 gives us 0. 3 times row 1 minus row 2 gives us 4. 3 times row 1 minus row 2 gives us a 3. We still need to generate row 3 numbers, so we're going to temporarily ignore row number 2, and we're going to take our pivot number and pair it with the other non-pivot number that we have in that column and try to think of how we can create a 0 with those. If they're both 1s, all you have to do is subtract them to create a 0. So we're going to use that as our set of row operations. So we're going to take that row 1 number and we're going to subtract where the 1 is located, which is not row 2, it's row 3. So we're going to do row 1 minus row 3. And notice that my row operation that I'm writing, row 1 minus row 3, is going in front of that non-pivot number row. So it's going in front of row 3 because that's where the answers are going to be placed. Now you're going to go one column at a time. Take row 1 minus row 3, write that answer in the next matrix. 1 take away -3 is 4. And our last column, 1 take away -2 is 3. And we've completed the cycle. We have, if you take a look at the column that contained our pivot number, we have now done what's called cleared the column. It is the only number in that column that is not a 0. So what we're going to do now is, in this new matrix, move to the next row, which would be row 2. and we're going to move to the first number that's not a 0, and that's going to become our new pivot number. It will give us a new pivot row and a new pivot column. The pivot row is not going to change, so we're going to transfer over row 2 as is, 0, 4, and 3. Which means in this particular problem then that row number 1 and row number 3 are going to change. So we need to take in that column, so focus on column 2, pair up the 4 with one other number that is not the pivot number, and think of how you could create a 0 in that position if it's not already a 0. If it was already a 0, then that row would not need to be modified. We would just transfer it over as is into the next matrix. But right now, that other number is a 1. So we need to think of how I can create a 0 using a 1 and a 4. So I'm going to take 4 times the 1 and subtract that 4 that's in the middle there, and that should give me a 0. So I'm going to write that row operation in front of the row that is not our pivot number. So the pivot number is the 4. The 1 is not our pivot number, which is row number 1. So I'm going to write my operations here in front of row number 1. So I was going to take 4 times the row number 1 value and subtract the row number 2 value. And I'm going to go through again one column at a time, performing that math. So 4 times row 1 minus row 2 gives me a 4. 4 times row 1 minus row 2 generates the 0. 4 times row 1 minus row 2 gives me a 1. Now I need to go back to that middle column. I need to now pair up my pivot number with the other number that is not a 0, and that's the row 3 number, and think of how I could take those two 4s and generate a 0, which would be by subtracting them. So I'm just going to take 4 minus 4 to create my 0 that I need. So I'm going to write that in front of that column, or row number 3. That was row number 2 minus row number 3. And now I'm going to go row 2 minus row 3 all the way down the line and put those answers below. So 0 minus 0, 4 minus 4, 3 minus 3. And now I have an interesting scenario that's happened here. This is covered in our special cases video for 4.2, and it's also talked about in the text. If you end up while you're working through a matrix where your variables and your totals all turn into zeros for their values, remember the first two columns were x and y, which are variables, our last column was our total, then you have a special situation in which one of these equations was not necessary. You have what we call a duplicate equation. And so on a graph, these would end up being graphed in exactly the same place. And we are ultimately trying to find where our point of intersection is located. When you get the 000 when you're working through row reduction, you can delete that row, continue forward with the 2 rows that you still have, and move through the steps like normal. So we would actually remove the 000 row, continue forward, moving through with our top row and our middle row, and try to finish out the process using row reduction steps. If, however, I had all zeros in my variables columns and I had a number of any kind other than 0, let's pretend like it's a 5 for a minute, that would be an indication that you had parallel lines, which means that we actually have no solution, and we would stop working on the problem and we would just write no solution up here at the top. So if you get all zeros for the variables and your total, that means that row is extra, delete it, continue forward with the rows you still have. If you had all zeros for the variables and some other number for the total, that stops the problem completely and you would have no solution, and you would move on to the next problem. But we can continue on because we do still have 2 rows that we can work with. And so we're on our final step since we have no other row to move to, no new pivot number to locate. Our job at this point is to convert each of the pivot numbers that we now have. So we go back and look at where those pivot locations were in those rows, and we want to make those numbers a positive 1, which can be accomplished by multiplying by that number's reciprocal. You're going to multiply that entire row by that reciprocal because if one number changes, they all have to change in that same way. So we're going to take 1/4 times everything in row 1, and that will turn the 4 into a 1. The 0 will stay a 0, and if you take 1 times 1/4, you get 1/4. This is the only time it's okay to introduce fractions back into your row reduction process in the modified method. This means that one of our answers is a fraction. We'll now go through row 2. The pivot number was a 4. Again, to get that value to turn into a 1, you would just multiply by 1/4. But every number in row 2 needs to be multiplied by that same thing. So 0 times 1/4, 4 times 1/4, and 3 times 1/4 would again be 3/4. And now we have our answer. Our x's are going to equal 1/4, and our y values are going to equal 3/4. Write that as an ordered pair where your x answer is first and your y answer is second, and you are finished.